Okay, folks, welcome to our next lecture. And let's see what this lecture is about. This is lecture 8. This is on asset data in the CryEngine flow graph programming. This is part of our, let me go back here. I'm supposed to always do this part. This is the CryEngine programming lecture series at SNHU. I'm Tom Adamson, visiting professor. Okay, so now we know what this is going to be about. Let's have a look at a table. This is data that a game needs to keep. It needs to keep all kinds of data. That is, when you stop playing the game, you come back and play it, it's got to have a place where it remembers what was going on. One way of displaying game data is in a table. Now here's a table right here. And this could look like our checkbook ledger. But this has information about some monsters. The name of this table is called the monsters table. Notice here that it has 3 records. A record reads from left to right along here. It has 3 records. It has a record with the name, Gorky, age 127, male, orc, fighter, level 12, health 256, strength 200, intelligence 50, and for those of you that are hardcore gamers, you know even a lot more information is kept. And the second monster, second record, is Mindy. She's 18, she's a female pixie, a ranger, level 3, and so on. Zambi is age 45, a female human wizard, and so on. So records read from left to right. These are called fields here. Like this is the gender field. This is the race field, the class field, and so on. So the table consists of 10 fields, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with 3 records. And there's 3 records within these within this table. The first field is called a primary key field. This field right here, the ID field, is called a primary key field. The PK field, primary key field, uniquely and minimally identifies a record. It's just like if you have a student number. Your student number is different from everybody else's student number in your school. Okay, we all have social security numbers. Each social security number is unique. All license plates for cars in the same state have unique identifiers on them. It uniquely and minimally identifies that car. So you want a way that when you're dealing with items within your game, like inventory and what have you, you want a primary key that uniquely and minimally identifies it. It helps your system find a record very quickly. This is a table display of asset data. Of course, the asset here are our monsters. The table name is monsters. Just to give you a rundown on terminology, table is a group of related records. Like these records relate to each other. They're all about monsters. A record is a group of related fields. These fields all relate to that particular record. These are things you would like to know about your monsters. A field is a group of related data. Like, for example, in this field, all the data here has to do with their names. All the data here has to do with their gender. All the data here is a whole number. It has to do with their age, and so on. A relational database, for those that are interested, is a group of related tables. And can you have that in an XML document? Yes, you can. Now, here's what we're going to do on the next slide. You're going to see how all of this was taken and put as an XML document, so it doesn't have to be displayed as a table. Because in order to keep your information like this requires a lot of overhead and a lot of work. I mean, it's worth it, but you got to know database design. You have to understand something about structured query language and what have you. So let's see how all of this looks in our XML file that we're going to create. So here's the XML form of exactly the same data. So the root element is the table name monsters. So let's look up here. There's the root element. There's this opening tag called monsters. I come all the way down here. There's this closing tag. Each record is enclosed with a monster element. I look, here's the first record. There's this opening tag, and I come all the way down here, there's its closing tag. So monster, the monster element represents one record. Here's another, monster ID equal 2. And there's the opening tag, there's the closing tag for monsters. Monster, M-O-S-T-E-R, is the monster element contains all of the other elements that are within that record. And there's the last record, monster ID equals 3. Notice the attributes for each of these monster records are being used as the primary key. Okay, and on the last one, if you notice with Zambi, age 45, gender female, and the race is human, class wizard, level is 24, health is 125, strength. She has a new field added that the other records didn't have. She has a field called mana, which is 250. Now, this is why XML is called extensible, because I can do this in XML and it's no big deal. However, if I were doing it with the table, I couldn't do it. So what you want to do is you want to carefully look at this here and compare it to the traditional table structure. Because what your assignment is going to be is to actually make one of these using a simple text editor. What we're going to do in the next slide, we're going to look at one of these records. We're going to take an enlarged view of one of these records. So let's go and click on this. So here's an enlarged view of the first record, monster. And this is the monster element. This is its opening tag. This is its closing tag. Notice remember, an element is an opening tag with its corresponding closing tag. And notice what's inside the element, the fields: name, age, gender, race, class, level, health, strength, and intelligence. And this is taken right from the table. The name of the XML file is mystuff.xml, and I use camel case. Indentation is done to make element relationships easier. So this indentation I did intentionally. It doesn't have to be there. Now, we know monsters, this right here, this is the root element. Monster, singular, ID equals 1, is a child of monsters. You see this right here? This is a child of monsters. Why? Because monster, ID equals 1, is contained within the monsters element. Therefore, monster, this element here, there's this opening tag, its closing tag, it is a child of that, okay? All right, now I don't want to go back here, and it's gonna, yeah, there we go. Okay, so monsters is the parent of monster ID equals 1. This right here, this monsters element is the parent of this monster element here. Why? Because this is what contains that other element. So what we're looking at are parents and child elements, and we're looking at siblings. All right, let's have a look. Name is a child of monster ID equals 1. Isn't that true that the name element is a child of the monster ID equals of the monster element? Why? Because name is contained within the monster element. The name element is contained within that. Okay? Name is a child of the monster ID. So this is a child of the monster ID. Name, age, gender, etc. are siblings. All of these elements, name, age, gender, race, class, level, health, strength, intelligence, these are all siblings. Why? Because they're contained within the same element. That's why they're called siblings. Okay. Monster ID 1 is the parent of name, age, gender, etc. So this right here, this is the parent of all these other elements. So what the important terminology here is what's a parent, what's a child, what's the root, and who are siblings here. And of course, knowing what an attribute is. Each monstered record elements contains all the fields for that record, and there's all the fields for that particular record inside monster. The ID attribute is different for each monster, and that uniquely and minimally identifies it. I'm going back intentionally here so we can see the ID attributes on each one of these is unique. So it'll be an easy way to find each monster record when we get into it. Okay, with that said, here's the steps that we're going to go through for our assignment. If you'd like to follow along with this, that's fine. Or you want to go back over this video and do it as a homework assignment, that's fine too. I want you to use a simple text editor with a .txt extension to create the XML document. This one right here. And I mean a simple text editor. I don't mean Notepad++. I don't mean any RTF. Nothing like that. Just use simple Notepad. We don't want any other characters, invisible characters, inside our XML document. Once we create it, we're going to change the extension from .txt to XML. And you'll get a warning message that if you do that, your program may become unstable. Just ignore that message. Say, yeah, you want to do it. So what you want to do is use Notepad, and effectively what you're doing, you're making that table, you're making a replica of that table for 3 different monsters with all that information. Then once you get that and you've changed the extension to .xml, go into your main CryEngine folder and go into the Game SDK folder. Open it and then put your file, my stuff, right inside that folder. Just like this, okay? Place it in the Game SDK folder of your CryEngine folder. All right, so that's where your engine's going to look for it. It's going to look for it there, at least for the example that we have. Then the second step is go and open the FlowGraph editor and open the XML node class and drag out the open document node, this guy right here. Of course, you want your start node. You want the output of the start node, this port here, output port, to go to the execute port here. All this does is it'll open the document and it'll ask you in the upper right hand corner right here, what's your file name? And your file is my stuff, and keep the camel case. And you don't need the extension XML. It knows it has to be XML or you wouldn't be doing it. The other thing here, the location, it defaults to map, and that's where you want to leave it because it'll look for in the development kit where you put it. Like, for example, it'll look for your file to be right here in the Game SDK where it says map. Okay. All right. Now, the next thing is what we want to do in the third step. We want to go to our debug and open up the display message. Open this one here. Open 2 of them. And you want it because we're going to test it now. We're going to test to see if it'll actually open that document. So if it succeeds, it'll come over here and show, and you want to make the message OK. If it fails, it'll come over here and show, and you want to make the message nope. And change the font size to 4. So then go ahead and execute play your game, your Control G, and then you should see the message OK. Now, just to make sure that everything's working, what you want to do is go back here to your file that's inside here. Whoops, I'm sorry, I missed it. Let me get to it. Let me get to it. Here it is. Go back to your file right here and change its name to mystuff.x.xml. Just change its name somehow, okay? And then go back, once you change its name, then go back here and try this program again. You should now see that it fails. You want to do this testing in order to make sure that everything's doing what it should be doing, okay? So you do a small amount of coding and a lot of testing. Remember that. Okay, very good. So let's see the next step we want to do. We can simplify these by clicking on these little buttons here. They don't have to be left open and stuff like that. So instead of having something that's taken up a lot of real estate like this, here, you can click on these little buttons here and it will simplify the nodes for you. Okay, you want to keep that in mind. That could be a big help. What our goal is we want to get the ID attribute value of our first monster. We want the system, the game, to get this ID value, which we know is a 1, but the game needs to know that. Note that monster ID equals 1 is a child of the root element monsters. So monster is a child of monsters. So we must get to the first child of our XML document and then get its attribute. So we've got to first get to the child, and then we have to get the attribute of that child. All right, let's see how we do that. So step four is we're going to get the node from the XML node class that says get child, and take small steps. First, see if you have success in getting the child element. Be sure to get the name right, monster. The child element is named monster, right? Isn't that true? Let's get over here and see. So this is a child of the root element, and it's called monster. And that's what we're telling the flow graph system. So we're going to get the game start, we're going to open the document, we're going to get the child, and we want to make sure that we got it correctly. So again, we put it to the display messages. And when we execute this with the Control G, we should see yes, okay, or go, or whatever it is that we put in here to affirm it. All right. Now step 5, you're now ready to display the value of the ID attribute in the monster element. And be sure to get the attribute identifier correct in the get attribute node. The attribute identifier was ID, lowercase. So I opened the document, I'm getting the child, and now I'm getting the attribute of that child, and the name of the attribute is ID. So if I have a success now, I want it to show that value. So notice I have a connection from the value port of the get attribute node to the message port of the display message. If it's a failure, it'll just display the message that says nope. But here, if it's a success, I don't want it to display okay or good or whatever I had there. I want it to display the value now, just to show that I got the value. So you do Control G here, you should see the value of 1. Okay, now what we want to do, we want to get the first field value for name. The name element is the child of the monster element. Hence, you need to add another getChild node and test it to make sure your flow graph is still working. So we're saying the name element is another child down. So let's just go back and verify that and see if that's true. Okay. Right now, I'm right here in my program, in this element, monster. Name, however, is a child of monster. Monster was a child of monsters. So I have to go down to two generations. I have to go to this child, and then from monster, which is now a parent of name, I have to now go to this child, and it's called name. If I want to get the name Gorky, or I want the system to get the name Gorky from that XML file, which is effectively a database. Okay. So what I have to do is I have to get child again. So the first child I got was monster. The second child I'm going to get is name, lowercase. And again, I test it to make sure that everything's working. Small steps, a lot of testing. Okay, and I do the Control G to get into the game to see that it's working. Now I can get the field value. You're now ready to get the value, the content of the name element. This is done by the getValue node of the XML node class. Now I've gone down for 2 children, and I'm looking for the field that's called name. And then once I get that, then I'm looking for what is the value. So here's the value right here. So if it's a success, it will now show this message here, and it will display the value. In other words, when I do a Control G now, I will see in the upper left-hand corner Gorky. Note that the value port of the getValue node is attached to the message port of the display message. Okay. So to review, here's what we covered. First of all, asset information can be displayed in a table. Any table information can be replicated in an XML file. Now, unlike table data, XML data is extensible. A primary key uniquely and minimally identifies a record. The XML node class is capable of getting data from any properly structured XML file created by the game logic designer. Okay, I'd like to thank you for your attention. Please feel free to leave comments and suggestions as we continue this lecture series. I will stay after the lecture to answer any questions or to go back over any part of this presentation. Okay, thank you again.